Okay, so the last video we looked at integrating sine squared and cos squared. We used the cos 2x identity. So what if we're asked to integrate cos squared of something else? Not just x, but 3x. Well, let me tell you how I'd approach it. I would firstly copy and paste my cos squared x integration. So we've just done that. Well, I've just done that. I don't know what audio you're watching videos. And then I'd say to myself, okay, what happens in this process if I replace this x here with 3x? So let's replace that x there with 3x. So this is 2 lots of x, so that's 2 lots of 3x now, so that's actually going to be 6x. And when you integrate cos of 6x, you get sine of 6x, not divided by 2, but divided by 6. And then when you multiply out the half, you actually get 1/12 of sine 2x. Note that the 1 stays the same. That doesn't involve x at all. And when you integrate 1, you get x. So that's still, you still end up with a half of x. So the only term that changes, and that needs to change as well, doesn't it? So 6x is that. So we can integrate cos squared x, and that means we can integrate cos squared anything just by firstly doing the cos squared x integral and then replacing x with whatever we're told to replace it with, remembering that that term doesn't change, but as well as that changing, the number you divide by also changes. So you could practice this perhaps by integrating sine squared of 2x, sine squared 2x. Go and have a go at that, pause the video, and I'll come back with a solution in a moment. Sine squared of 2x. Okay, so here's sine squared x, that's the one we did in the last video. So I'm now going to replace x with 2x, and so that means this becomes 4x. And when I integrate it, that means I'm dividing by 4. And so a half times a quarter is an eighth of sine 4x. And again, that one still becomes an x, still becomes half x. That's not affected by that change at all. Good stuff.